guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 2421 that says number of good paths. So here we are given a tree that is connected undirected graph with no cycle consisting of n nodes and numbering from 0 to n minus 1. Further we are given one values array where values of I denotes the value of the ith node. So we need to return the number of distinct good paths. So the definition of good path is the starting node and the ending node must have same value as per this values array. They must be having the same value. And another thing is all the node between the starting node and the ending node must have value less than or equal to the starting node. That means all the intermediary nodes of the path should have value less than or equal to the starting node. So we need to return number of such distinct good paths. So since we need to return distinct, so that if 0 to 1 is a good path, then 1 to 0 is considered to be same. Okay, and also one thing to note here is a single node is also considered a valid path. So now let's take a look at this first test case to get better understanding. So here you are given one graph of 0 with 5 nodes, and the edges are like this as shown. So here, since there are 5 nodes, so 5 is the minimum possible answer. Then there is one another path from this node 1 to node 4, 1 to 0, 0 to 2, and 2 to 4, such that the starting node and the ending node has the same value, and all the intermediary nodes have value less than or equal to starting node. So this is a good path we can consider. So this is one such good path. So total answer is 6, 5 for the nodes and 1 this path. So you can see here that node 0 has a value 1 and node 3 has a value 1. But you can't take this path from 0 to 1, 0 to node 3 because the intermediary node has value greater than the starting node. Okay, so I hope you guys understood the question as well as how we are calculating the number of good paths. So now let us take a look at this another example. So here also you are given 5 nodes so since there are 5 nodes, so minimum possible answer is 5. Then this is one good path from 0 to 1, both has value 1, that is starting and ending node has value 1, so you can consider this as a good path. So now the answer is 6. Also there is a good path from node 2 to node 3, so our final answer is 7. No other good path is possible in this graph. Okay, so let us take an example of how we would solve this question. Let me draw this graph. Let me give some value numbering. Okay, so here you might be thinking that to find a good path, what you would do, you can do traversal, like DFS traversal. So from each node you can do a DFS traversal from node 0, then node 1, then node 2, node 3, and node 4, and calculate the number of good paths based on the condition. That means if the starting and the ending node has the same value as well as the intermediate nodes has value less than equal to starting node, then what you would do, you would return 1, else you would return 0. So with this logic you can code a DFS function, but this will give you time limit exceeded error, that is TLE, because you are traversing each node, and for each node you are traversing for the best possible path. So this will take a time complexity of big O of n square, and this will surely give you TLE. So we need to think of a better approach to solve this question. So talking about the better approach is see guys, one thing to note here is if you start from any node to any node and find the good path, then it is not possible. So what we will do is either to divide this whole graph into subgraphs, or we can do is we can take one node and start building the graph. So one possible is, let's say you make this as a one possible as a subgraph, let's say not including this and this. So let us take two on this type of separate subgraphs by deleting some of the edges. And else what you can do, you can take a node, you can start building a graph like this based on some condition, okay, up to the complete graph. So these are the two possible ways. So if you might be thinking that why we are either deleting some of the edges or making a graph like this, so that at every time we added another node or a node, we will check for a good path, because we have pre-computed the value of this and we are adding one node. So this is like a prefix sum. You can think that we have a sum till I minus 1 element, and if we add the ith element, then we can directly use the previous answer. So this is something like this. And since we are making so this is a bit harder approach to code, but this is simple means it is simpler than this. Why? Because we have one data structure, that is disjoint set union. So what disjoint set union does, it make union. Okay, so with make union we can create edges, right? Like if you want to unify 0 and 1, yes, we can create the edge between 0 and 1. Then this 0 and 2 also. So this function will do that. And it also has find parent function. So we will also use this parent function later. Okay, so till now what we have understood is we can't use DFS because this will give us this would be an n squared approach and would give us TLE. So we need to find some better approach. So the better approach could be if we start building the graph by adding one edge at a time and use the pre-computed value and simply using DSU we can make union and add edges. So this is one way. But another thing to note here is let's say you have some graph like this. Let me just draw 0, 1, 2, 3. Here all the nodes are value 5. So the possible good paths are the node itself, then the edges like 0 to 1, 0 to 2, 0 to 2 to 3, then 1, 0, 2, and 1, 0, 2, 3. Okay, and yes, 2 to 3 also. So how many total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total 10 good paths here. But if you use this, if you like try to replicate this in the form of DSU, then you will have one parent and you will make union where vals are same. So if you want to do this with the help of DSU, you will take one node. If you find a similar node, a node with a similar value, you will make it. And at the end, a node, let's say for this graph, the node means there would be 4 nodes with same parent. Okay, so that would, let's say if 0 is the parent, then it would be parent of node 1, parent of node 2, as well as parent of node 3, and 0's parent is 0 itself. So if we so using this make union, you will make edges, and using this parent you will find how many, so you will find the frequency of a parent. So the frequency of a parent as a node 0 is 4 here. Then what you will do, instead of finding this all the different edges, we would take help of this 4 value 4, because as you can see here that this is 10 and the frequency of 4, then if you do n into n plus 1 by 2, this will also give us answer 10, because 4 into 5 by 2 is 10. And this is sum of n numbers. But you might be thinking how we derived at this formula by using this 4. So as you can see here that if for this given graph, if we start from node 0, so for node 0, how many good paths possible is one node itself, then 0 to 1, 0 to 2, 0 to 2 to 3. Okay, for node 1, the one node 1 itself, then 1 to 0 we can't include, so we include 1 0 2 and 1 0 3. For node 2, how many possible? The 2 itself and 2 to 3. So here it would be 1 0 2 3, and for the node 3 here it would be 3. So what you can see here it is n minus 1 possible path, n minus 2 possible path, n minus 3 possible path. So we are, what is this? This is simply sum of n numbers. Okay, because we are adding this to get total good path. So I hope you guys understood that why we come up to this formula, because if you divide these and find, if you find the number of good paths from each node, you will come up to this solution for all the graphs. So we can directly use this by taking the frequency of a parent node. Okay, so till now what we have cleared is we will use DSU, we would make union, and you will use find parent and on frequency of parent. what we would do n into n plus 1 by 2, sum of n numbers formula. So I hope these things are clear now. Now let us again move on to this example. So you can see this example here. So what we would do, we would initially take the node with the least value. We would add adjacent node to that node whose value is less than equal to that value, and then we would find frequency of parent and we would add it to our answer. And we would take, what we would do, we would take n into n plus 1 by 2, where n equal to frequency, and we would add to our answer. So if let me go through this graph and do a dry run so that you guys will get a better understanding. So initially we have two nodes with a value 1. So we take node 0 and node 4, both have value 1. So all the adjacent node or the child node of both these nodes have value greater than equal to 1. So we don't add any adjacent node here. Then we calculate the frequency of parent. The frequency of node 0 is 0 itself. Sorry, the parent of node 0 is 0 itself, and parent of node 4 is 4 itself. So here its frequency, so let me write its frequency is 1, and here is also its 1. Now if we do the sum of n numbers for this one, then it would be turned out to 1 and 1. So our answer here would be 2. Okay, so this was one case where we solved for nodes with a value 1. Now we will take nodes with a value 2 in our picture. So we have nodes with a value 2. Now we add one of its neighboring node, that is node 0, and another node 4, because both these nodes have value less than equal to 2. So whenever you will add the edge between node 0 and node 2, you will make any one of it as a parent. Okay, so talking about the parent of this node 2, we will keep parent of nodes 2 as node 2 itself, because it has the greatest what we can say value here. So we keep node 2 as its parent as itself, so its frequency would be 1. So if applying this formula on the frequency, we would only get 1, so our current answer would be 3. Okay, now in situation, what we have 3 as the maximum value. So let me take these 3. So initially we are taking this node 1, then we are adding the edges like node 0, node 2, node 4, and also node 3. Okay, so here we are making node 1 as a parent of all. So node 1's parent is 1, we are converting 0's parent to 1, 2's parent to 1, 4's parent to 1, and 3's parent to 1 as well. So this is, now we are getting the complete graph. So now checking the frequency of a parent of node 1 and node 3, because these two nodes are added just now. So here the frequency would be turned out to 2, because the parent of 1 would be 1 itself, as well as 3's parent would be 1 itself. Because what we are doing in DSU, we are just doing its path compression. Whenever we add edges, we would do like this: 1 to 2, 1 to 4, 1 to 3. So this parent of node 3 would be 1 itself. So this is due to path compression. Now if we do sum of all n edges, that would be turned out to be 3 here, and if we add 3 to this 3, we will get 6 as our answer. So this is our final answer, as no more nodes are there further in this graph. So I hope you guys understood this solution, that we are taking the nodes with the least value, then we add any child node if it is possible, then we calculate the sum and we check our answer. So this we did for all until all the nodes are visited and we are getting our answer. Okay, and for this above example, what we would, if we would start from here, let's say node 0, then this would be the same case. We added all the at only one time only we would add all the edges, because all the nodes are less than equal to 5, and in that case we would simply do the sum of n numbers and it would be turned out to 10. Okay, so now let's move on to the coding part, where we will understand this approach via code in a better way. So here this is the standard code snippet where we have two adders, it is parent and the rank. We have two functions like find parent and make union. So now let me just clear it out and let us write code again. So initially what we would do is we would make one adjacency list for better traversal. So let me make vector int adj of size n. Now before that we have to define n as a total number of nodes here. So we get from vals.size. Now I would traverse all the edges and make an edge into this adjacency list push back e of 1. Since the graph is undirected, so I will also push one edge from both the ends, like 0 to 1 and 1 to 0. Okay, now further we would make an object of DSU of size n. Then what we would do, now we want to find the least values, or we want to traverse all the nodes based on incrementing their values of here, as we did here, that to get the least value and traverse it in such a way. So for that I will take one ordered map. So it is an ordered map and store the nodes with a value in the index. So let me take value to node, and I will traverse its vals at here. I would simply do value to node of vals of I dot push back I. So what we are doing is, if a value is 3, then what I would do, I would then our vector would be 1 comma 4 based on this, because two nodes have a value 3. So we are mapping the value with the vector of indexes or vector of nodes that has this value. Now further we would traverse this vals to node for auto. So let me take it as value comma nodes of value to node. So that means we have taken one of the nodes with one of the nodes, let's say node 0. Now what we are trying to add edges. So to do that we have to travel for the adjacent elements of this node. So let us first take one node from the list of nodes, and we would traverse all the adjacent element to this node for auto, or the neighboring element of this node, and we would check if vals of the neighbor is less than equal to vals of the node. Then we would simply do make union, that is we would simply add an edge, the edge between the node and the neighbor. So in the case let's say if our node is node 2 with a value 2, then the neighbors are node 0, node 4 and node 3. So we will make an edge between node 0 and node 4, but not with node 3. So let's say for an example, we have node 2 as our current node, and the neighbors are node 0, node 3 and node 4. So what we can do here is, we will make an edge between 2 and 3 and 2 and 0, but not with 2 and 4, because the value of the neighbor is greater than value of node or the current node. So this is how we make union. So this will make a graph here till now. And further what we will do, we will again traverse this nodes array and find the frequency of the parents. So to calculate the frequency, we will take unordered map int and let me name it frequency of parent, and we would again travel all the node present in the nodes, and we would just increment the parent frequency, that is frequency of parent of dsu dot find parent of node plus plus. And in the end what we would do, we would traverse this frequency of parent and do the sum of n numbers and end it to our answer. So before that, let me initialize one result variable to 0. Now we would traverse frequency of parent, int count is it dot second into it dot second plus 1 divided by 2. and we would simply do result plus equal to count, and in the end we would return result. Okay, so now let us try to run our code. So yes, all the test cases are passed. Now let us try to submit this. Okay, so our code got accepted. So as you can see here that we are using this TSU, and then we are sorting based on the map. We are using map for sorting based on the value, and then we are traveling the nodes, making the union, finding the frequency of the parent and applying that formula of sum of n numbers and then adding to the result. So yeah, this was a bit complex problem to understand and approach the question. So now talking about the time complexity. So guys, as we are inserting n elements into this map, and since the map will sort according to the keys, this will itself take n log n time complexity. And also here we are adding the edges, this will also take n time complexity. So overall we can say that the time complexity for this code would be n log n, as we are using this map here. And for that, for the space complexity, it would be big of n, because we are storing just n elements inside this DSU. That will contribute to big of n. And yeah, and everywhere we are just taking for n elements. Here also there in the map there would be n keys at max. So yeah, the space complexity would be big of n, and the time complexity would be big of n log n. So that's all for the video. I hope you guys liked the video, understood the solution as well as the code. And if you still have any doubts, do let me know in the comment section, and make sure you like the video and subscribe to our channel. Thank you.